Welcome to qnawire.
We have the harmonic oscillator in its ground state. We know its wave function, and we have a expression to find A. We're asked to find the ratio between the probability amplitude, aka psi squared, for plus or minus A versus x equals 0, and same thing for 2A versus x equals 0. So the first thing we can do is to start by getting an explicit expression for A. So we have 1/2 Ka squared equals 1/2 omega. Thus, you can get A squared isolated, h bar over omega over k. And from this point, we can make note that omega is equal to root k over m, just from some classical oscillator physics. So once we can get that in there, we have h bar over root km. And we can take a square root of that to get A by itself. So now we want to square psi, and then we'll eventually plug x equals A in. So psi of x, we don't need to worry about any complex conjugates because there are no complex numbers anywhere. So we have c squared e to the negative root mk x squared. Actually, I think it should be 2 root mk h bar x squared. All right. That's just doing some exponential math. So when we plug in x equals 0 into this, it will zero out this exponential, have it be e to the 0, which leaves us with our c squared. So by dividing, if we plug x equals A in, and we divide this by psi 0 squared, we're just going to cancel. We're just going to drop the c squared out. We're going to end up with e to the negative 2 root mk over h bar. At this point, you can plug in a squared, which should give us h bar root mk. A little bit of simplification, and we are left with e to the negative 2. Okay, not bad, not bad. One small mistake. There should be a 2. The original wave function has a 2 in the denominator here, so when we square it, we are just left with this. There should be no 2 here. So this should be e to the minus 1. I thought something was fishy there. Okay, that's correct. So just be careful about the original wave function you're using here. Now for the psi 2a, it's going to be essentially the same thing, same kind of idea. Dividing by the x equals 0 location just simply cancels out the c squared, and we are left with root mk h bar, except now we're going to have a 4 h bar root mk because we're squaring the 2. We're plugging 2a in, we square it, get 4. Everything will fall out in the same way. We are left with e to the negative 4. And that's it. So how does this compare to the plot? Well, if I recall, the plot looks something like this when we get the amplitudes. Where it has some maximum and it decays like some exponential. Oh, and it's symmetric on both sides. And yeah, it falls off at some 1 over e squared sort of thing. So it makes sense that the ratio is going to be much, much smaller out when we're out at 2a than at a. So say it looks good. All right, and that's what we're asked to find.